Hello students, welcome back to my channel. So in this video we are going to start a new chapter on polynomials, which is a quite important chapter for your class 10 CBSE. Okay, so in this video we will see some basic concepts related to this chapter. Then we shall see the way to solve problems, right? So let's first check out the definition of polynomials. So students, I suppose that you have some basic concepts about polynomials because you had this chapter in your class 9, right? So I suppose you had some, you just have some basic concepts about it. Okay, like you know the meaning of degree. Okay, you know what is a polynomial, what is biquadratic, what is a cubic polynomial, what is quadratic. Okay, so let us see, just for recapitulation, let us see the definition of polynomial first. So if you define a polynomial, it is basically an expression in the form of this. Okay, so this is the way of writing a polynomial. I hope you know this, that is, you write a letter and in the bracket you write the variable, right? So here x is the variable. So this is basically polynomial in one variable because we are writing only x. Okay, so px is in the form a0. A0 means the 0 is like the first term. Okay, 0 plus a1 x to the power 1 plus a2 x square plus a cube a3 x cube plus, and it will be going up to the nth term. I will say nth term. Nth means the natural, n means the natural number. Okay, so it will go up to the nth term, so it will be an x to the power n. Okay, and the most important thing that you need to know is basically an cannot be 0. Okay, so the value of an is 0 because if the an is 0, the term will become 0, right? So an should not be 0. Is called a polynomial in x with degree n. What is degree? Basically degree is the highest power in a polynomial. So in this particular general form of polynomial, you can see that the power is gradually increasing, right? So what is the highest power here? The highest power is of course the n, right? So we say that it's a polynomial of in x of degree is n, right? So you can see I have written over here that a0, a1, a2, these are all the real numbers. Okay, and each power of x should not be negative. So each power of x is a non-negative integer. Now a confusion may arise that why I have striked off positive and written non-negative, instead of positive, because both mean the same technically, right? Non-negative means positive. So this is because if I write positive, I am not including 0. Okay, to include 0 I am writing non-negative. Means if you take the number line, so if you have 0, 1, 2, here minus 1, minus 2, so I'm just, it should be non-negative, means this negative portion should omit, but you can of course include 0 in this process. So from 0 to the positive infinity. Okay, so I have written non-negative in place of positive because we are including 0. Okay, so this is a basic definition of polynomials. Let us see some examples. Okay, so you can see I have written some examples. So if you see, this is a polynomial in y, right? Because you have y as a variable here. So if I write in the I can write f of y. Okay, so because y is the variable, so I will be writing a letter and the variable I will write it inside the bracket. And this is how you write, denote a polynomial. Okay, so this is the highest power in this polynomial is what? Degree is 2, so the degree will be 2, so it is a quadratic polynomial. Okay, this is a quadratic polynomial, right? So, and one more thing is, see, you can see the power is all the powers is non-negative, right? This is 2, this is 1, so, and 8, here you have y to the power 0, because we know that anything say x to the power 0 is always 1. So basically you have a power over here which is 0. Okay, so every powers are non-negative, means all the values of all the powers of x are non-negative. Okay, all the powers of variables are non-negative, so it is a polynomial. In the next example, you can see you have power which is gradually decreasing, that is 4, 3, 2, 1 and 0. So basically the highest power is 4. First of all, say that this is a polynomial because all the powers are non-negative, right? So you can say this is a polynomial in t, right? The variable is t, so you can write p of t. Okay, so the highest degree is 4, so the highest power is 4, so the degree of this polynomial will be 4. So this kind of polynomial is called biquadratic polynomial, right? But as you can see, the next one here, if you consider this as the polynomial, it is in the denominator. Okay, if you write this with the help of, like, with respect to the numerator, what will be the result? The powers will go negative, right? Because we know that, when we write by the laws of exponent, if you write 1 by x to the power n, if you write this with respect to the numerator, what will be the result? It will be x to the power minus n. So the power is becoming negative. So in this case also the power will be negative. So we are getting negative powers. So this kind of expression are not polynomials. Okay, so I hope this concept of polynomials, degree, these things are clear. I just, for information, I'll tell you that if you have degree 1, it is called linear polynomial. If you have degree 2, that kind of polynomial is called quadratic. Okay, in case of degree 3, it's cubic, and in case of degree 4, it's biquadratic. So okay, so in your syllabus you will be dealing with mainly the first degree and the second degree polynomial, that is linear and quadratic polynomial. In some cases you may find a few cubic polynomials, okay, but biquadratic, this is not, like, you will not get that much of problems, okay, as of now. So now let's define zeros of a polynomial. Okay, now let's define zeros of a polynomial. So zeros means basically a term. Okay, zeros means, suppose you have a number, a real number alpha. Okay, this is a real number. So this is called the zero of a polynomial if a zero of a polynomial px. Okay, so px is a given polynomial. Okay, so a real number alpha is called the zero of a polynomial if p of alpha is 0. Okay, so if you put alpha in place of x, the result you will get is 0. For example, say I have a polynomial px. Okay, so px is given to me as x square minus 2x minus 3. Okay, so let us say alpha is 3. Okay, and minus 1, like there are two values of alpha. Okay, let us assume. So let us put 3 first in this polynomial. So I'll be finding p of 3. So I'll be putting 3 in place of x throughout the polynomial. So I'll be getting 3 square minus 2 into 3 minus 3. Like it is 9 minus 6 minus 3. So 9 minus 9 is 0. So you can see over here that if you put x equals to 3, the polynomial is becoming 0, right? You are getting a result 0. So we can say that this 3 is a 0 of this polynomial px. Okay, now let's take this one also, minus 1. So I am finding p of minus 1. So if I put minus 1 in every place of x, so it will be minus 1 whole square minus 2 into minus 1 minus 3. So it's 1, it is plus 2 minus 3 plus 2 minus 3. So I'm solving it. This is 1 and this is 2 minus 2 in 1s are 2 minus 3. So you are getting 2 minus 3, 2 plus 3, 2 plus 1 is 3 minus 3, that is 0. So you can also see that if you put x minus 1, then the value is 0. Okay, so we can say that minus 1 is a 0 of this polynomial px. Okay, so I hope the concept is 0 is clear. So let me take another one. Let us say you put 2 in place of this x. So it will be 2 square minus 2 to the 4 minus 3. So it will be 4 minus 4 minus 3. So you are getting minus 3. So if you are taking 2 in place of x, so you are getting minus 3, which is not 0. right, which is not equals to 0. So you can say that 2 is not a 0 of this polynomial px, right? So I hope the concept of 0 is clear. Okay, so now let us talk about a very important result, that is degree of a polynomial that is equals to number of zeros. So this is a very important thing, a very important relation, okay, that you need to remember, that you have to, like, if the degree of a polynomial is 3, then you will have 3 zeros, right? So you will have three values for which that polynomial is becoming 0. Okay, you will have 3 values of that variable for which that polynomial is becoming 0. So let me take the previous example. The previous one I wrote that the previous polynomial was this, right? This was my px. So can you tell me how many zeros will be there for this polynomial? There will be 2 zeros because the degree is 2. Okay, so I have written the degree of a polynomial is equals to number of zeros. If you have a cubic polynomial, for that there will be 3 zeros. Okay, if you have biquadratic polynomial, that is degree 4, you will have 4 zeros, right? So this is a very important relation that you need to keep your mind. Okay, now let's talk about relation between the zeros and coefficients of a quadratic polynomial. Okay, so in this chapter we will be mainly dealing with the quadratic polynomial and cubic polynomial. Okay, so first let us see the quadratic polynomial. So let us say you have a quadratic polynomial, that is px. Okay, so the value of px is, let us say we are taking a general form of this polynomial, that is ax squared plus bx plus c. Okay, where a is not equals to 0. Okay, because if a is 0, then the whole term, if a is 0, then this will not be a quadratic polynomial. Okay, this term will vanish, so it will not be a quadratic polynomial anymore. Okay, so I have written a is not equals to 0. Okay, let us say that alpha and beta are the zeros of px. Okay, so I'm assuming that this polynomial will have definitely two zeros because the degree is 2. Okay, so let us say alpha and beta are the zeros. Okay, so then if these are the zeros, so alpha, x minus alpha will be the x minus alpha, and x minus beta will be what? Are the factors of px, polynomial px, right? Why? Because if these are the zeros of this polynomial, so this will also be 0, like x minus alpha will also be 0, right? So in this case we will be getting x equals to alpha, so this is satisfied, right? So in this case also, since beta is the 0 of this polynomial, so we can write x minus beta is 0, so we'll be getting x equals to beta. So these things are satisfied, so we can say that x minus alpha and x minus beta are the factors of this polynomial px, right? So you have this general form of the polynomial. So if you factorize this, what will be the result? If you factorize this, then you will get 2 of its factors, that is x minus alpha and x minus beta. I'm talking about middle term factorization. I hope you remember middle term factorization that you have learned in your junior classes. Okay, so in quadratic polynomials we used to do middle term. Okay, so if you factorize this by the middle term, you will be getting factors like this, right? Okay, so x minus alpha and x minus beta will be the factors along with the constant k, because you will be having some constant k. Okay, so where k is any real number, you will be having that, right? So you can say that upon factorization we are getting a value something like this, right? Okay, so can we write this a x minus alpha into x minus beta? So we are basically doing middle term, so you will have x square, okay, minus alpha plus beta x, which is the form of middle term. I hope you are getting it. Okay, so this will be the factorization of this one, right? Okay, so if you multiply this, multiply the k, so it will be kx square, right, minus k alpha plus beta into x plus k into alpha beta. Now do one thing, now compare this thing with the general form that you have considered. You considered general form this, like ax square plus bx plus c. So you will compare this one with this one. So what will be the value of a? So a will be here k. Just compare these two, okay? b will be what? Except x, take the whole thing, that is minus k alpha plus beta, right? And what will be the value of c? C will be simply k alpha beta, right? Because it's fully constant, so c will be the whole thing. Okay, now see, the value of k is a, right? So we can put the value, we can substitute the value for k in these both things, right? So we can write b is equals to, the value of k is a, so a into alpha plus beta, okay? And here c is equals to a alpha beta, okay? So you keep this alpha plus beta in one side, so you will be getting what? Minus b upon a, right? And if you keep this alpha beta in one side, so you will be getting c upon a. Okay, fine. I hope up to this is clear. So we can say that the sum of zeros are basically, these were the zeros, right? So the sum of zeros are nothing but the ratio of, the negative ratio of coefficient, of x upon coefficient of x square. Can we say that b is what? B is coefficient of x, right? Oh, okay. So and a is a coefficient of x square. Okay. So can we say that the sum of zeros in a quadratic equation, the sum of zeros is equals to minus coefficient of x minus divided by coefficient of x square. On the other hand, can we say the product of zeros of a quadratic polynomial is equals to the constant upon a, that is the coefficient of x square. So I'm just writing it in words. So if I write this in words, then I can write sum of zeros is minus coefficient of x upon coefficient of x square, and the product of zeros is basically the ratio of constant and coefficient of x square. Okay, so I hope the concept is clear up to this. So basically, students, these are the things that you need to remember. That is, the first one is this, and the second is, if it is given in the question that you have two zeros, that is alpha beta, then the corresponding polynomial will be this, okay? X square minus the sum of zeros into x plus the product of zeros. So if you have the coefficient of x, if you have the coefficient of x square, if you have the constant, if you have the coefficient of x square, then you can easily find out the sum of zeros, and also you can find out the product of zeros, and thus you can also find out the corresponding polynomial. Okay, so let us check out the very first problem on this topic. So the question is, obtain the zeros of the quadratic polynomial this, okay, and verify the relation between its zeros and coefficients. So what is the given polynomial? So let me assume that let fx, I am just denoting the polynomial as fx. So fx is given root 3x square minus 8x plus 4 root 3, right? So what is the way of finding the zeros? You have to find the zeros, okay? So for finding the zeros, what we shall do, we shall try to factorize this, okay? So this can be factorized with the help of middle term. So if you do the middle term, then it will be root 3x square upon 6x, okay, for root 3. So from here you can take root 3x as common, so you will be left with x minus 2 root 3x minus 2. So see, here so this is the result you are getting, okay. So for finding the zeros, what will be the condition? F of x will be 0, okay. So if f of x is 0 means this will be equals to 0, therefore x minus 2 root 3 into this will be equals to 0. And you already know the relation that if AB is equals to 0, then A is 0 also, B is 0, right? So here x minus 2 root 3 is 0, and so you will get the x 2 root 3, and also root 3x minus 2 will be 0. So you will be getting x equals to 2 upon root 3, right? So this is the relation you are getting, like this is the zeros, these are the two zeros you are getting upon factorization. So now what we have to do, we have obtained all the zeros, this is done, and now we have to find out, we have to verify the relation between its zeros and polynomial. So I can say this is my alpha and this is my beta, okay. So to verify, so what was the relation? That is sum of zeros is equals to the coefficient minus of coefficient of x upon coefficient of x square, right? This was the formula, this was the relation. So let us verify it. So if you put here, so what is the coefficient of x? If you check the polynomial, the coefficient of x is minus 8, right? So the minus of minus 8, okay, and the coefficient of x square, that is under root of 3. So this will come as 8 upon root 3, okay. So is it matching the sum of zeros? Let us now find out the sum of zeros. So sum of zeros will be what? Alpha plus beta, if you find out. So it is 2 root 3 plus 2 upon root 3. So it is root 3 as LCM, and then 2 3s are 6 plus 2, so that is 8 upon root 3. So you can see this relation is satisfied. So you will write that therefore sum of zeros is equal to minus coefficient of x upon coefficient of x square. So the first relation is satisfied, okay, the first relation is verified. And now the product of zeros. So what was the relation? It was constant by upon coefficient of x square. Just verify that. Product of zeros, what will be the product of zeros? It will be alpha beta will be what? 2 upon root 3 into 2 upon root 3. 2 root 3 upon into 2 upon root 3. So we will get 4. And let us check this. So the constant term was what? The constant term is this, 4 upon root 3. Okay. So constant term is 4 upon root 3. Sorry, not 4 upon, it's 4 root 3 upon coefficient of x squared. So the coefficient of x squared is root 3. So see, you are getting 4. So both the values are same, means product of the zeros equal to constant upon coefficient of x square. So the relation between is zeros and coefficient is verified. Okay. Okay. So the second term, the second problem is if one of the zeros is, if one zero of a polynomial, that is this is your given polynomial, is a reciprocal of the other, then find the value of a. Okay. So So let us go according to the question. So it is said that let one of the polynomial, because it will have two polynomials, two zeros, right? Because the degree is 2. So let one polynomial be alpha, okay, and let other polynomial, sorry, the zeros, this is zeros, let one zero be alpha and then the other zero be beta. So according to the question, it is said that the other one is the reciprocal, okay. So you can say that beta is reciprocal of this, that is 1 upon alpha. So we can say that we have two zeros, that is alpha and 1 upon alpha, right? So now if you find the product of zeros, that is if you find alpha beta, so the result will be alpha into 1 upon alpha, so you'll be getting 1. So the product of zeros is 1. But by the relation of coefficient and the zeros, what do we know? We know that product of zeros is equal to what? Constant term upon the coefficient of x square, okay. So let us put the values accordingly. So the product of zeros is 1, right? What is the constant term over here? So 6a is the constant term, so we can write 6a upon coefficient of x square. This is what? A square plus 9. So the coefficient of x square is a square plus 9. So if you solve this, we will be getting the value of a. So that is a square plus 9 equals to 6a, that is a square minus 6a plus 9 equals to 0, right? So now this is what? This is a square and you can write this as 3 square, so it is 2ab. So a square minus 2ab plus b square, it is nothing but a minus b whole square is equals to 0, okay. Then a minus 3 will be 0. If you under root both the sides, if you take the under root on both the sides, it will be 0, okay. So a will be 3. So this is your required answer. Let us look at the probably the last numerical, that is find a quadratic polynomial whose zeros are 1 and minus 3. So the zeros are given, so we can say alpha is given as 1 and beta is given as minus 3, okay. We have to find the quadratic polynomial. So let us find the sum of zeros first, that is alpha plus beta. So it is plus 1 plus minus 3, that is minus 2, and alpha beta is 1 into minus 3, that is minus 3, right? So what will be the polynomial? So the required polynomial will be what? It is x square plus minus alpha plus beta into x plus alpha beta, right? This was the form, okay. Just put the values over here. So you'll be getting alpha plus beta is minus 3 minus 2, so it will be minus and minus, it will be plus, so 2x plus minus, that is minus 3, so it will be 3, okay. So this is the required polynomial. Now you have to verify the relation between the coefficient and zeros. So let us find, that is the sum of zeros. See, sum of zeros is minus 2, so I am directly writing this. So it is minus 2, it should be equal to the negative of coefficient of x. So what is the coefficient of x? It is 2, and upon the coefficient of x squared, that is 1. So it is becoming true, so it is verified. And also the product of zeros, that is minus 3, should be equals to the constant term, that is minus 3 upon the coefficient of x square, that is 1. So this is also verified, right? So I hope this video helps. more or less the numericals, like the problems are of this kind only. So make sure you check out your NCERT book and practice all the problems from there. Okay, so in the upcoming videos we will be proceeding with the chapters. Okay, so I hope this video helps, and if it helps, please show your support by liking this video and subscribing to my channel. So as of now, thank you and take care.